Hi students, today in this video lecture we will be solving problems based on simple harmonic motion to find the time period for different oscillating bodies. I will be doing another 2-3 days the same chapter, and try to subscribe to the channel so that you will be able to see more videos on how to find time period for different oscillating systems. Okay, so today the first one I have taken is, you can see the question. This is a solid cylinder. Okay? This is a solid cylinder whose mass is given 2m. Mass is given 2m, and it is resting on a horizontal surface. On top of that cylinder, there is a plank or a stick, you can imagine, whose mass is m. It's connected to a spring or spring constant K. Okay. Right now everything is in equilibrium, so this spring is neither stretched nor compressed. It has been mentioned that no slipping occurs at any surface, neither here nor here, so no slipping. Okay, and then what happens is you have to displace it slightly this way or that way, and then release the system. Then this body will start oscillating, and this cylinder will also oscillate this way. Okay. Now, since it has been mentioned no slipping, this point of the cylinder and this point of the lower surface must have at every moment same velocity. So the 2 points which are in contact, if there is no slipping, that means what? This point and this point, they should have same velocity at every instant. So if this is at rest, this point also should be at rest. If this is moving with 2 meters per second, this point also should be moving with 2 meters per second. So in that way, there will be no slipping between the two surfaces. If one will move faster than the other, then there will be slipping. So the ground below, this point is at rest, so this point on the cylinder should also be at rest. Whereas this plank will be oscillating, right? So therefore, whatever velocity this point on the plank has, this point on the cylinder should also have same velocity and therefore same acceleration. So how do we find time period of oscillating bodies? First, what we have to do, we have to displace it from its equilibrium position and then see what torque or what net force will bring the body back. Right? Once we find the force, we divide that by mass, that will give you acceleration. Right? And if you can find the torque, then we divide torque by moment of inertia about the axis of rotation, that will give you angular acceleration. And whatever comes here, there should be some constant times displacement, and here some constant times angular displacement. And if the motion has to be simple harmonic motion, then it means what? Simple harmonic motion means what? To and fro motion. So if displacement is to the right of the mean position, net force should be towards the left of the mean position. So if this is in the positive direction, this should be in the negative direction, so there should be a minus sign, right? In both the cases, whatever this quantity will be, that will be your omega square. Once we find the angular frequency, then time period is given by 2 pi divided by omega. So let us see in this situation how the system will be oscillating, or how the body will be moving to and fro about the mean position. So right now this is the mean position, so let's imagine this line. Okay. Now let us imagine this has been pushed by a distance x. Then this spring will also be compressed by x, right? And this point, cannot have any velocity because this lower surface is at rest and they said no slipping occurs. So this line should turn this way by some angle theta. Fine? Okay. So this angle will be theta. So now you know that this point in the block has moved a distance x, and therefore this point in the cylinder should also move by that distance x. So that will be your x, right? So that x will be equals to how much? This whole distance is 2r. So this arc will be 2r times theta. Fine. So once we find this x, let us draw the free body diagram for the plank. After you have displaced it, and then when you release it, we have to see what forces or what torques brings it back. So in this case, when you displace the body towards right by x, the spring gets compressed this way, so there will be a spring force this way, right? So there will be spring force here, k into x. X is how much? 2r theta. So you can write here 2r theta. What about the friction here? There will be some friction, right? So coefficient of friction is, let's say, mu. So there will be some friction. How to find the direction of friction? This plank, when you leave, because of this force, right? You are trying to draw the direction of friction at this instant, okay? So when you leave it, it tends to go this way, right? So this point wants to slide this way. So friction will be on that surface this way, okay? And let us say the acceleration is A of the plank. Then you can write Newton's second law for this. Since acceleration is this side, kx minus friction equals to mass of the plank is m times A. This is equation 1. So this equation we have developed for the plank. Now let us see the cylinder. Okay. This friction on the plank is applied by whom? Whichever is in contact below, and that is the cylinder. So from Newton's third law, the reaction of this friction will act on the cylinder this way, right? And since this force alone, if it was there, the center of mass would translate this way. But you know this point cannot go this way, because that point should be at rest with respect to the lower surface. So this point wants to slide this way, so friction on that point will be this way. Let us call that F dash. Now let us say this body has, the center has an acceleration AC. Okay, so what will be the Newton's second law? F minus F dash equals to mass of the cylinder is given 2m into AC, equation 2. Okay, now till now we have not found, there is no displacement coming in the picture, right? So yes, in x there will be displacement, that is there, x is there. But what is performing SHM is, see, the way the body oscillates, this cylinder will go like this. With that, the plank will go this way. Then it will come like this. Then it will reach mean position. Plank will come here. Then the cylinder will go this way. That time the plank will go this way, which means the spring will be stretched. So it is this angle which is oscillating this way, right? So it is angular SHM. So let us try to calculate the torque about this point, O, which is this point, right? So torque on the cylinder about O will be equals to, about O there may be some normal force, but that will pass through O, so that will not create torque. Mg will also pass through this point, so that will not create torque. This friction is also passing through this point, so that will not create torque. So the only force left is this F. So it will be F into R perpendicular. This will be your R perpendicular, which is 2R, right? So that is the torque, and that torque should be equals to moment of inertia about O, because you are calculating torque about O, times alpha. Okay, so alpha will be friction into 2R divided by moment of inertia about O. Moment of inertia about O, how, what will be moment of inertia about this axis? Since this is cylinder, about this axis we know what is the moment of inertia about this axis. Half mass of the cylinder is 2a. So half mass into R square. There is the moment of inertia for a cylinder about an axis passing through its center of mass. But I want about this axis. So we will apply perpendicular axis theorem. So mass into perpendicular distance, which is r square. So that will give you 4, this 2 and 2 will cancel, so this will be 3 mr square. That is the moment of inertia of the cylinder about this axis. So that will give this, I can replace this by 3 mr square. So that will be 2 times friction divided by 3 mr. Now I need to bring here theta somehow, because I want to write alpha in terms of theta. Now this friction has x, and x will have theta, right? So that is good thing, because we can substitute this friction here. But this a will be also there, right? Okay, so what do we do with this a now? So let us get some space. So to find a, so a is acceleration of this plank, which means acceleration of this point in the cylinder. Okay, now you know that this body is rolling without slipping. So what is the condition for rolling without slipping? VCM equals R omega. If you take differentiation of this, you will get ACM equals to R alpha. Right? Now, acceleration of this point in terms of this, how can we write? Let us say this has acceleration ACM. Then this will have how what acceleration? ACM plus R alpha. How do I get this? Okay, if you are not clear regarding this, so then you have to slightly go back to the concepts of system of particles. See, rolling basically is combination of translation and rotation about center of mass. So imagine this system is only rotating about center of mass. Then it will have velocity here, r omega. Here it will have velocity r omega. Every point will have velocity r omega like this. This will have r omega like this. If it is pure rotation, no translation. So r omega, right? So this would be the motion as seen from the center of mass. Now if center of mass is not moving, then that will be the motion with respect to ground also. But if center of mass is moving with respect to ground, then velocity of this point, let us say center of, because I assume omega is this way, right? So VCM should be here in order for pure rolling to occur. So if I say that center of mass is moving when I see from ground, then when I see this point with respect to ground, its velocity will be what? Its velocity will be velocity of this point with respect to center of mass, which is r omega, plus velocity of center of mass. But velocity of center of mass is this section, okay? Minus vc. And here it will be, if you forget about this point, it will be plus vc. Okay? So when translation occurs, and this will be with this velocity, you have to add this velocity. With this velocity, you have to add this velocity. Okay? So once you add these two velocities, that will be the velocity of any point here or here with respect to ground. So once you have understood this point, so you have understood that when a body is moving with velocity VCM and also rotating with angular velocity omega, this point will have a velocity VCM minus r omega, and this point will have a velocity VCM plus r omega. But if you want rolling without slipping, then this point should have zero velocity, same as this ground. That means what? VCM should be equal to r omega. That means here it will become 2 VCM, because r omega is VCM. So acceleration of this point of the cylinder is, if you take differentiation, this is the velocity of this point. So if I call this P, that will be Vp. So then if you take derivative both sides, you will get acceleration. So acceleration of point P will be what? Twice of acceleration of center of mass. Take differentiation of this equation. Okay. So if you have understood this, we have realized that this cylinder now has center of mass acceleration AC, and this point will have 2 times AC, right? And what is ACM? VCM is R omega, so ACM will be R, derivative of omega is alpha, so this will be 2 times R alpha. Okay, so acceleration of this point is 2R alpha, but that acceleration of this point should be same as acceleration of the Planck, because no slipping is anywhere, neither here nor here. So acceleration of the any point of the Planck and this point of the cylinder must be same at each instant. So in place of this A, now I can write, let us substitute for x also. So what will be x? X will be 2r theta minus friction equals to, in place of ACM I can write acceleration of this point A, I can write 2r alpha. Okay, so friction becomes finally, if I take this side, this one this side, k into 2r theta minus 2mr alpha. So let us now substitute this friction in this equation. So alpha will be equals to 2f by 3mr, and what is f? K 2r theta minus 2mr alpha, right? It is a friction. So if you open this, you get 4 r and r will cancel, k theta divided by 3m minus 4 alpha divided by 3. So mr will cancel. Bring this side, you will get 3. So this will be alpha plus 4 alpha by 3 equals to 4k theta by 3m. That will give you 3. 7 alpha equals to 4k theta by 3m. 3 and 3 will cancel. So alpha will be 4k by m 7m theta. Now if you put vector signs, then angular displacement is this way, but this torque was due to this friction, so that will be this way, so there will be a minus. So now if you compare this with SHM equation, this must be your omega square. So time period will be 2 pi divided by omega. This is omega square, so omega will be root of this. So here it will be 2 pi divided by omega, so root of 7m by 4k. So I hope you all understood. So here the concept of rolling without slipping is very important. Thank you.